this is recording. Okay, so linear regression is a linear regression. We have a few types of regression, but we only cover for linear regression and only simple and multiple linear regression. Okay, all right. Okay, so this is a learning chapter. All right. So normally, people confuse between correlation and regression. Okay, you can see this when you want to start your research, your BRM, business research later on. I think in another two semester, you will start your research proposal. So this you will find this is quite confusing between correlation and regression. Okay. Alright, so correlation, normally we will use a scatter plot, okay, to visualize the data. To correlation and regression both is must have at least two variables, okay. So normally when you have more than one variables, okay, we have two variables, then we want to show the relationship. So the scatter plot is the tools that we can use to visualize this relationship, okay. Okay, so correlation, okay, this is one of the technique. Correlation, normally we just use this correlation to analyze or to measure the strength of the strength of relationship between two variables. Okay, just want to identify the relationship, okay, and the strength for that relationship, whether there is a relationship or not, and how strong is it. Okay, all right. So that is the difference between that is correlation. Okay, we just want to see there is a relationship or not, no causal effect. Okay, example, let's say between me and one student. Okay, so we want to identify the relationship to see whether me and that student have a relationship or not. Okay, all right. So how strong is that relationship? Okay, we are very close. Okay, close enough. Okay, whatever it is, that student will come to me. So that's only that relationship, okay, to identify the relationship. Okay, so to visualize, okay, this is the scatter plot. Okay, when we plot the relationship, we want to see whether it's a positive. This is a positive linear. Okay, when we say linear, this is a straight line here. Okay, so linear relationship, straight line positive or negative relationship. Okay, this is a negative relationship. Alright, so this is a curvilinear relationship. What we will not cover in this course. Okay. Alright, so focus on the linear relationship. Okay, so how strong is it? Okay, so this is quite strong. You can see the plot, the dot here is near to the center line. Okay, so this is very strong relationship. Okay, there still have a relationship, but a weak positive relationship. This is a strong positive relationship. Okay, so still there is a relationship, but a weak relationship. Okay, so when you have this is a negative, okay, positive, negative, strong relationship, strong negative relationship, and this is weak relationship. When you plot in the scatter plot, then you get this graph, okay, this plot like this. Okay, so this means that this is a weak positive relationship. Okay, like this is a weak negative relationship. This is just to visualize lah, okay, to visualize your data. Okay, so you already based from this data, based from this graph, you can identify your relationship, but you still did not get the figures, only to visualize. Okay, general idea. Okay, when you get something like this, okay, you cannot see the pattern, means that there is no relationship. Even though this is a strong, but you can see that the dot is near to the center line, but still no relationship. Okay. All right. So and regression. Okay. So that the things that you want to cover in this chapter is more focused on the regression. Okay. So when regression, we can see that there is some impacts. Okay. So impacts from one variables to another variables, and also that we can use to predict for the future. Okay, based from that relationship between that two variables. Okay. All right. So example. Okay. Correlation. Okay. The example correlation. Correlation. We just want to see whether me and X student have a relationship or not. or me and A students have a relationship or not, just to see that whether there is a relationship between me and that student. Okay. The regression, what regression want to measure is that you want to see how can I affect that student. Okay, whether whatever I say, whatever for me, the solution from me, I give it to that student, whether will it give any impact or not to that student. Okay, so that is the regression, to see the impact from me to the other to A student. Okay, so that then we can use that whatever I say to that students, you can see the impact from that suggestion. Okay, so that is a regression, different. Okay. Correlation, just want to see the relationship, how strong am I. Okay, I have a relationship, maybe that student is very close to me, that's it. Okay, all right. But regression want to see how can I impact to that, give impact to that A student. Okay, and then also based from whatever behavior from me towards that A students, so can predict the outcome in the future. Right, so that is a regression, right? Okay, remember that in a regression we have two variables. Okay, so first there is two different types of that variables. Okay, so one is the dependent variable and the other one is independent variable. Okay, in simple linear regression. Okay, so in simple linear regression we have only one independent variable. Okay. Alright, so dependent variable is the variables that you want to predict, okay, or the variables that you wish to explain, okay. Alright, so independent variables is that the item or the variables that you use to predict or that you use to explain the dependent variables, okay. Example, right? Okay, so I want to study the grade for BBA student based on time spent for study. Okay, average grade, okay, or average CGPA or CGPA students based on time spent on study. Okay, there is two variables. Okay, average students. So the things that I should the data that I should get from the student. One is their average and the other one is the time that spent to study. Okay. Alright, so there's two variables there, time and grade. Okay. Alright, so we will use time that spent to study to predict the grade for student. Okay, so you have to understand the relationship. Okay, you cannot use a grade for student's grade to predict time to study, isn't it? Okay, you cannot use that. Okay, so normally we use maybe in the very special study, in certain special cases. Okay, maybe you want to see that use a grade to predict time that need to spend to study. Okay, that is another cases. Okay, let's say we want to predict average, so based on the time spent to study. Okay, so that the dependent variable is average, the grade, student's grade. Okay, that is a student's grade, depends because of this average grade is depends on time they spend to study. Okay, so independent variable is the time spent to study. Okay, because you want to use these variables to predict student's grade. Okay, right. So you have to clearly understand which one is a dependent and which one independent. Okay. Okay, so like I say, simple linear regression, only one independent. That the only difference between multiple and simple linear regression. Okay, simple only one independent. Multiple is we have more than one. Okay. 2, 3, 4, 5, okay, more than one, right? Okay, then there is certain cases that we have another regression, which is you have two dependent or more than two dependent variables. Yes, you still can measure that, but there's a different cases lah, complex linear regression. Okay, so in for this chapter, for this course, we focus only simple and multiple linear regression. Okay. And then the relationship between x and y is described by linear, okay, linear function, okay, not curvy or others function, okay. All right, and then and this is an assumption, okay, or a condition to use a simple linear regression, that we assume that changes in y to be related to the changes in x, okay. So it means that whatever changes in y will affect the x, okay. What if you change the time, if you increase the time for you to study, then you will get a different will change in your in the different grades, okay. So depends on whether it's a positive or negative relationship. If a positive relationship means that if you increase your time spent to study, then you will increase your will increase the student's grade. If you reduce the number the hours for you spent to study, then your grades will reduce, okay. So that is a positive relationship. But if you find out based on your data, okay, if you increase the time to study, then the average then students average will drop, then there is a negative relationship, okay. Right. Okay, so this is a equation, okay, for simple linear regression. This is for population, equation for population regression model, okay. All right, we have y. This is y, dependent variable, the things we want to predict. Okay, we use a y. Okay, okay. This is equal to y equals to mx plus c. I think that is from, I'm not sure, maybe it's in your secondary school, it's in this your high school or secondary school, you already learn this function, y equals to mx plus c. You know this equation? Have you learned about this equation, y equals to mx plus c?
For me, this is the first time.
Oh, first time, okay. It's good if you inform me the first time, okay. So because I assume that everyone know this equation, right? Okay, so y equals to mxc. This is the original equation, okay. But they convert to based on they convert based on the application. So in the business, so they convert it like this, okay. All right. So this is a linear equation, because a linear equation, okay. Alright, so C is equals to here, okay, and MX is in the business like this, okay. So this is intercept, okay. So this is for intercept. C is for intercept. For population, we use a beta, okay. So beta 0 is for intercept, okay. So in the graph, remember that linear graph, okay. Alright, so this is the BO, okay, intercept. When X equals to 0, okay. When this is equals to 0, here is 0. Okay, what is the y value? Okay, the minimum value for y. Okay, when x equals to 0. So that is an intercept. Intercept between y vertical line. Okay. All right, and then this is intercept. This is a slope. Okay, slope. Beta 1. This is for population. Okay, so beta 1. So beta 1 is the slope for this graph, okay, slope here, okay. So okay, slope. That later I will show you how to calculate this, okay. All right, so this is slope and this is x value lah, okay. So based what you okay, so for regression model, okay, so to develop the equation for regression, you should have a history data, previous data, okay. It cannot be done if you just want to start. This is the new things that is difficult for you to create this equation model, okay. You must have a history data. Based from history data, we want to predict for the future, okay, or want to see the pattern there, right? Okay, so means that it must be happened previously. Then you have a data collection there. Okay, all right. So this is a slope. Okay, slope here. Okay, beta 0 is intersection. Okay, so this is a random error, but normally we doesn't include lah random error component. We don't include in our equation in this course. Okay, all right. So up until here only. Okay, so this is the graph explain. Okay, right. So here is a intercept here. Okay, and this is a slope, beta 1. Okay, so now remember that when we have a data, okay, in the statistic, we collect based on the sample data. Then based from that sample data, then we will create the regression equation. Then we can use that to predict for the future. Okay, so based from the sample data, right? Okay, so that one, the previous one is equation for population. Okay, so for sample, okay, so equation based from the sample, we use a small b and small b0 and small b1. Okay, still the same. This is a intercept and this is a slope. Okay, only that the symbol, the notation here we use a different from the we want to differentiate between the population. Okay, all right. So this is a estimated y based from this equation. Then we can estimate the y. Okay. All right. So we will use a method here, the least square method. Okay. This is manually if you want to calculate manual, but I won't show you manual. Okay. We just based on the computer output. Okay. Okay, so this is a coefficient beta 0 and beta 1. Okay, so the coefficient here. Okay, so coefficient beta, we will identify, we get the value coefficient B0 and B1. Oh, okay. First we go directly to the problem. Okay, right. So before I show you the data, right. So the problem here, okay, when this is the problem to explain this about the simple linear regression. Okay. All right. So now problem is a real estate agent wish to examine the relationship between the selling price of a home and its size. Okay. Want to identify the relationship. Okay. The size is measured in a square feet. Okay, right. Then they collect the random sample of 10 houses. Okay, only 10 houses. Okay, so then they identify that house price, they want to estimate house price based from the its size. Based on the size. Okay, all right. To estimate the price based from the size. Okay. All right, so price is the dependent variables, okay, and independent variables is the square feet, the size, okay, right? So the size is independent variables and the price is dependent variables, okay. In the question, in the exam, you should identify this, okay. You have to identify which one is the dependent and which one is the independent, okay. Later on, I will give you one example, okay. Full question that then you can identify which one is the first you have to identify which one is dependent and which one is the independent. Okay. All right, so this is the data based from the 10 sample house, okay, that this company collect. Okay, so what 10 houses, okay, so house price 245, then the size is 1,400 square feet. Okay, 312. Okay, the price is in square feet is 1,600. Okay, square feet. Okay, so based from this history data, so this is the data. Okay, we call this existing data. Okay, means that this is existing house lah. Okay, all right. Then we can when you plot, then you can see plot in the scatter plot diagram. Then you can see the pattern here. Okay. You can see generally you can see there is a relationship between house price and the square feet and the size. Okay. Okay, so this is how you can run. Because you don't have to do it manually. Okay, you can get the you can create the equation from the computer output. You can use Excel only. Okay. All right. So how to use it? Then when you have the data, go to the data ribbon here. Okay. You don't have to do this, okay? This is just I explained to you very briefly, okay? If you want to do that yourself, then you can do it, but not in the exam, okay? So go to the data ribbon and then you will pop out this window, okay? Then select the regression, okay? data, and then you select this data analysis here button, and then choose the regression. Okay. Okay, so then you identify, you have to select range which one is a X. This is where you have, that's why you have to identify first which one the dependent and which one is the independent. Okay, if you select wrong column, then you will get a different equation. Okay, all right, so which one is a Y and which one is a X. Okay, so house price is a Y and the square feet is a X. Okay, we use a size to predict the house price. Okay, then after you click OK, then you will get this computer, the Excel will generate this computer output to you. Okay, this is a computer Excel output for simple linear regression. Okay, so then you in this linear regression, you just have to interpret besides you can differentiate between the dependent and independent. Okay, so you have to understand every figures in this computer Excel output. Okay, right. So it's only based on the interpretation from this Excel output. Okay. All right. So first we want to create the regression regression equation. Okay. So remember for the sample equation is y hat. Okay, predicted y equals to B0. This is B0 is intercept, okay, plus B1 and B1x, okay, all right, x lah, okay, so x1, x2 later on if you have more than independent variables, okay. All right, so how you can get this when you do not have to calculate, only you can identify from this table, okay. So where you can get the intercept value here, intercept value is in the last table here. You can see the intercept coefficient, okay. So this is the value for B0, okay. So intercept B0, this is the Excel output is standard, okay. All right, and then B1, okay, is from the second row in the last table here, okay. So coefficient for square feet is 0.1. So then you transfer to the equation here. House price equals to 98.248 plus 0.10977 times by square feet x. Okay, so x is a square feet here. Y, house price is a y. Okay, so this is the equation for this problem. Okay. All right, based from this data, okay, based from this data, you key in the Excel, then you generate, you get the computer output here. So based from this computer output, you can generate the equation. So this is the equation to predict the house price in the future. Okay, all right, using this equation, y hat equals to 98.248 plus 0.10977 x. Okay, square feet is x, house price is y hat. Okay, until now, do you have any question? If not, then I will just proceed. Okay, no question. All right, so okay, so this is you plot it in your table. You don't have to plot lah. So this is just to explain. Okay, so intercept here, intercept. You can see intercept when the x equals to 0. So this is the intercept here. Okay, all right. So and the slope. Okay, the slope of this this graph. Okay, so this is slope. All right. Okay, so remember that the data. Okay, the data that you used previously. Okay, so you use previously is range from the 219 up to 405 only. Okay, so that's why this is the range here. Okay, so this is the range your data. So then when you draw a line here, you get this like, okay. Okay, so now you have to interpret each figures, each coefficient in this equation. Okay, Alright, so B0, okay, B0, okay, how we is the estimated average value of Y when the value of X is 0, when X is 0, okay. Alright, so when X is 0, so this is the minimum value for Y, okay. So when you put X ni equals to 0 times by 0.1, so you get 0 here. So the minimum value for Y is 98, okay. But in this case, not all problems that you can interpret when X is 0, Y equals to 98. Okay, if you want to interpret in that problem, means that if size, okay, square feet is 0, means that no size lah, okay. So the minimum price for house is 98,000, okay, 98,000 because it's in the thousands, 98,000, okay. It's really not logic because if there is no house, okay, means there should be no price lah, okay. Size is good, so not in all problems that you can interpret. When X is 0, that is the minimum value for Y, okay. However, still you will get the value for intercept, okay. So just like this, because okay, it doesn't mean that there is a intercept here, okay. It's just only when you expand your line, then you will get intercept here, okay. Alright, but still in this case you cannot interpret that. When size is 0, then the minimum house price is 98,248. Okay, that cannot be interpreted like that because that's not a practical application. That you cannot have a 0 square feet and the minimum house price is 98,000. Okay. Alright, so then for B1, okay. For B1 is the estimates, okay, the slope here is estimates the change in the average value of Y as a result of 1 unit increase in X, okay. So when you increase one foot, okay, 1 square foot, okay. When you increase 1 square foot in your house size, okay. Alright, so the house price will increase by 109, okay, 110 lah, 0.77 kan, 110. When you increase 1 square foot, then the price for the house price will increase about 109. Okay, that's how the interpretation of slope here. Okay, so if you increase 2 square feet, then the increasing in house price is 109 times by 2. Okay, right. So that's to see the increasing in X will affect the Y. Okay, so that's how you want to see the effect of X to Y. Okay, so another function that why we want to use a regression to see the effect from X to Y. Okay, alright, understand or not? Okay, so let's say X equals to X. Sorry. Oh, okay, tak apa. Okay, so this is how we can use to predict, okay, to see the changes. Okay, so now you want to use this equation to predict the price for a house with a 2,000 square feet. Okay, alright, you can use this equation to predict. Let's say if someone want to buy the house with a 2,000 square feet, then you can just replace X with the 2,000 here because the square feet is a X. Okay, you will you can estimate that the house price is about 300,000 and 317,000, okay, and 850. Okay, so this is the prediction price for a house with a 2,000 square feet size. Okay, so that you can predict the house price lah. Okay, all right, so based from this is the original data here. Okay. Okay, so however, your prediction ni only relevant, okay, So it's only relevant between the range here that you use a range. Means that remember that your data here, okay, between 200,000 up to 400,000. Okay, so you can use this equation. Okay, so sorry, you can use this equation to predict the sorry, 200,000 lah. Okay, so between this square feet. Okay, so you cannot predict, let's say you want to predict the size is about 10,000 square feet. Okay, so it's different. Okay, there's probability, the changes to probably difference in changes. Okay, alright, so you can use up to about 1,000 square feet up to probably maybe 300,000 or not more than 4,000 lah. You can use to predict the house price. If more than that, then maybe you need to collect more data, okay, to get the broad range, okay, the more range for the house, the size and also the price, okay, so then you can get a better prediction, right? Okay, so it's relevant in that area only. Okay, the next that what we want to see in the regression is that we want to see the correlation coefficient and also the correlation. Okay, all right. So correlation coefficient. Okay, so we want to see the related degree of relatedness of that variables lah. Okay, to that two variables. Okay, coefficient of correlation we use a symbol R. Okay, so R tu we want to see the relationship lah, linear relationship. Okay. Alright, so the figures you can get is between -1 to +1. So in between this, okay. So if the numbers is near to 0, means that there is no correlation, no relationship lah. Okay. So if your number is more near to -1, -0.7, -0.8, more than 0.6, more than 0.5, then you can see that there is a negative strong relationship. Okay. Alright, if the figures for R you get near to +1, okay, 0.5 and above, then you can see there is a positive relationship between that two variables. Okay. Alright, so near to +1 or near to -1, there is a strong relationship. But if the figures is near to 0, then it's quite weak relationship. Okay, even though there is a relationship, but weak relationship. But if the figures is 0, means that there is no relationship, okay, between that two variables. Okay, so when you see you plot the data there, okay, you can see this is a positive relationship, negative relationship, and no relationship. Okay, still in the based from the Excel output, okay, from this table. So we already explained the last table. Okay, so next we will see in the first table here. Okay, so this is a R, multiple R. So this is a R value. Okay, you get because of you get a positive 0.76. Okay, means that there is a positive relationship between X and Y. Okay, so all the relationship between X and Y is direct and positive. It's quite strong lah. 0.76 near to positive +1. Okay, all right. Okay, so only based on this table, you can interpret the correlation coefficient R value. Okay, so R value can be from -1 to +1. Okay, in between that values only. Okay, so next that the next information is based on for coefficient of determination R squared. Okay, alright. So coefficient of the determination R squared. Okay. We want to see the portion of the total variation in the dependent variable that is explained by variation in the independent variable. Okay, so the R squared ni, okay, it will explain the variation in the independent variable that explained by the independent variables. Okay, alright, so this is how you get the R squared. Okay. And R squared, the value from R squared, because R can be negative and positive, but R squared, you already squared the R value, then the value should be from positive to positive, 0 to positive 1, positive value only. Okay. Alright, so this is equal to 1, okay, positive, really the perfect relationship, okay. Alright, positive and negative, okay. So this is quite weak, okay, in a relationship. This is no relationship if r squared equals to 0, okay. So then you can refer to this r squared, okay. So r squared here is where this table get the value from is that when the computer calculate is based from these two figures, okay, SSR and SST, divide by, then you get 0.5808, okay. So or you can get directly from this, the second row from the first table r squared. Okay, the value should be from 0 to positive 1 only, okay. Okay, so based from this value 0.58808, we can conclude that 58% of the variation in the house price is explained by variation in square feet. Okay, so the variation the variation in house price ni only explained by 98% in the house size. Okay, means that you have another 42%. Okay, the variation or effect in the house price ni explained by the other variable, but we're not sure what is the other variable. We don't know that. Okay, only the square feet ni affect house price is only 58%. Okay, quite. I mean that 58% effect is not very high lah. Okay, quite low. Okay, more than 60%, then we can use that to predict. Okay, means that there is another important factor that we should consider. Okay, so only 58% that size ni affect the house price. Okay, you have another balance of about 42. 42, is it 42? 100% minus 58, about 42 lah, isn't it? Right. Okay, so 52%. The variation in house price is explained by the other variable, but we're not sure what other variable. So you should do some more research lah to identify that. Okay. So because of this data only based on the square feet, then we found out that only 58% the variation in house price explained by the house size. Okay. And probably that this result maybe because of the sample size is quite low lah. Okay. Sometimes the sample size also will affect the result for the relationship. Okay, all right. So this is a formula manually lah. If you want to do manually to identify the standard error of estimate. Okay, right. So what is the standard error of the estimate? Where do you get the value here? Standard error of the estimate. Okay, so standard error. Okay, SE. Okay, so it's a measure of the variation. Okay, want to see the measure of variation of observed Y from the regression line. Okay, so we get the regression line here. Okay, so want to see the variation of each point to from the center line. Okay, all right. So based from this value, okay, we get only 41.33. Okay, so how we can conclude that is that only it's about 41,000. Okay, the variation in the house price. Okay, so it's quite small. Okay, so the variation is only 41,000. Means that the difference between the average difference between the house price and from the regression line is about 41,000 only. So it's quite small. Okay, if the variation in SE is quite high, okay, let's say you get 100k, then means that the equation is not really cannot be used to predict the future. Okay, so we expect if you want to use the equation, first you have to identify the relationship, the r squared, r value and r squared, and then also you have to make sure you have the variation quite low. Okay, so very low variations that is not difference from the regression line. Okay, so if you have this large SE ni, the weak relationship, but it's very difficult to use to predict DV, dependent variable, using the IV. Okay, right? If there is a weak punya relationship. Okay, so if it should consistent. Okay, and there is a consistency between the R square and SE. If you get very low SE, if you get very low R squared or R value, then you should expect that the variation is very high, quite high. Okay. All right. Okay. So this is inference. This is only we use this to interpret the sample, our data. Okay. We use that to interpret our data, history data, sample data, and then based from that we develop that equation. Then we can use the equation to predict the future. Okay. All right. So another topic is that we want to use that sample to identify whether the population, when we identify that there is a relationship or the relationship using a sample data. Now we want to see whether there is a relationship for population or not. Okay, so we want to test the hypothesis testing. Okay, so but I will continue this inference ni, inferences about the slope ni, I will continue in the next class. Okay, I am sure that we cannot finish in 5 if I continue with the inferences. Okay, this is what hypothesis. Okay, we want to do a hypothesis for the slope. Okay, so I will continue in the next class. All right, if there any question from you?
No, doctor.
All right, okay, so now no question. Remember that, okay, so remember that on Monday is our last live class. Okay, we don't have a class on a Friday. But I will share with you after Monday. Maybe on Thursday I will share with you recorded lecture. Pre-recorded lecture with you to cover the rest of the topics. Okay. If I cannot finish on Monday. Okay. All right. Okay. That is
Okay,
all.
doctor.
Okay. See you on Monday. Bye bye.
Thank you.
Okay. Have a nice day. Assalamualaikum.
Assalamualaikum, Doctor. Bye.
Bye.